Okay, this is our last section of Module 2.6, Form Follows Function, a practice understanding task. In our work so far, we have worked with linear and exponential equations in many forms. Some of the forms of equations and their names are, so in this chart right here that you see in your notebook, we have equations on the left, and the name and some of the information we see over here on the right. So the equation y equals 1/2 x plus 1. Well, what form is that? That's y equals mx plus b. And that is what? Slope-intercept form, where m is the slope and b is the y-intercept. So if I look at an equation in slope-intercept, I see the slope and the y-intercept immediately, and I'm able to graph the perfect line. So in this problem, the slope m would be the 1/2, meaning I'm going to rise 1 and run 2, a slope of 1/2. And my b is my y-intercept, and that's going to be a 1. And with that, I can graph it immediately. Now, let's look at this equation. Y equals 1/2 x minus 4 plus 3. That's point slope form, where m is the slope, so the slope is still 1/2, and x sub 1, y sub 1, and this module used a and b to mean the same thing right there, but x sub 1, y sub 1 would be the coordinates of the point on the line. So when I have an equation in point slope, I see the slope, which is still 1/2, but then I see x minus x sub 1. So the x coordinate of my point will be a 4 plus 3 plus y sub 1. The y coordinate of a point would be 3. So now, instead of a y-intercept like I have above, I have a point. And when I graph this equation in point slope, I start with my point and then do the slope from there to get my second point so I can do my line. And then finally, f of 0 equals 1, and f of n equals f of n minus 1 plus 1/2. Well, that's recursive. That's a recursion formula right there. F of n equals f of n minus 1 plus d. All right? Now, given an initial value, f of a, d is the constant difference in consecutive terms, used only for discrete functions. So when I have a discrete function, I'm going to use recursive. Okay, but now I can still see the slope because, again, d is the constant difference in consecutive terms. Do you see this plus 1/2 right here? That's my pattern of change, meaning I'm going from a point, I'm going to rise 1, and I'm going to run 2. So I have a slope of 1/2 still. And then b, well, f of 0 equals 1, so my y-intercept is 1. And this is my initial point that I start with, right there. Okay, so let's practice by graphing these. So, and again, I want this to be automatic for you guys. One of the most important things we learn in the first quarter of algebra right here. So y equals 1/2 x plus 1. My thoughts are, well, what's the slope m? Well, there it is right there, 1/2. And what's the y-intercept b? Well, there it is, b equals 1. Now, in slope-intercept, we start with our y-intercept. In this case, that's a 1. And now, from this y-intercept, we're going to apply our slope. So we're going to rise 1, and we're going to run 2. So from this point, let's just go up 1, and let's go over 2, and put another point right there. And 2 points determine a line. And if I just have an equation, that's implied that this would be continuous. So I'm going to draw a solid line through those 2 points. There's my graph. Now, let's do the next one, which is in point slope form. So my slope is still 1/2. But now, what's the point that I go through? minus x sub 1. Well, the x sub 1, or the x-coordinate of the point I'm going to go through, would be a 4, plus y sub 1. The y sub 1 would be a 3. So now I'm going to start at the point 4, 3. So let's find 4, 3. X equals 4. 1, 2, 3, 4. And then go up 1, 2, 3. Oh, it's right on that line right there. And now I'm going to do my slope of 1/2 from here. So if I rise 1 and I run 1, 2, I'm going to have another point right there. Guess what? That's the same line. And this is an equation, y equals something in terms of x, so it's implied it's continuous. And that means my line would be that solid line still. Okay, now when I have a recursive formula, I am no longer continuous. I'm going to be discrete. All right, so let's go back a second here. So my initial condition, f of 0 equals 1. Okay, well that means when x equals 0, y is 1. So at x equals 0, let's go up to 1 and put a point right there. And then my recursive formula, or my recursion equation, f of n equals f of n minus 1 plus 1/2. So my pattern of change is I'm going to add 1/2 to every output. If you think of it like that, well, I'm at 1. If I add 1/2 to 1, I go over here and I add 1/2, I'm going to have a point right there. And then I'm just going to keep adding 1/2s. Isn't that cool? I have room for one more here. Let's see if I did one more. I certainly did. So this is the graph of f of 0 equals 1. And f of n is the previous term plus 1/2. We added 1/2 every time. We just went 1/2 higher every time. And whenever we have a recursive formula, we are considered discrete. There you have it. Great stuff. Make this automatic. All right, now we have a second chart, and look at our equations. We have an explicit equation and a recursive equation right here. And these are exponential. So the explicit form of y equals 10 times 3 to the x is y equals ab to the x power. Right there. Now, I need to know what my a and my b are and what that means. So here, the a gives me my f of 0. And this is a 0 because I'm only to the x power right there. All right? So f of 0 is this a right here, which is a 10. And my base of this exponential is the same thing as the common ratio in a sequence. So it's an r, and that would be this number that I'm taking to the x power, 3. So this means I'm going to take every output and multiply it by 3 to get to the next output. Okay, now my recursive formula. All right, now they used a little different notation here. Not really, they're using n's number 1, and they just put their common ratio times f of n. So they're using f of n plus 1 in terms of f of n, and we usually go like f of x equals f of x minus 1. That doesn't matter. This works too. And I'll show you our notation so you see it the way you usually see it. Okay, so what does this mean though? Well, my initial condition is f of 0 equals 10, just like above. So f of 0 is 10, and that 3 is my common ratio. I'm going to multiply every output. Like my first output is 10. 10 times 3, my second output would be 30. So my common ratio is 3. Okay, now let's graph these. Oh, here's the notation we have used. These mean the same thing though. So we usually do this like this. F of 0 equals 10, and then instead of going f of n plus 1 in terms of f of n, we go f of x in terms of the previous term, f of x minus 1. They both mean the same thing, and we like to put our pattern of change to the right, but you can put it on either side. I'm going to put a times 3 over here on the right. Okay, this means the same thing as this above. Now let's graph. So y equals 10 times 3 to the x. Now remember, and watch this carefully, my first output is 10. F of 0 equals 10. So, well, that's 1, 2, 3, 4. I better rescale my y-axis. So, and I'm multiplying by 3, so these numbers are going to get big fast. So I went 40, 80, 120, 160, 200, 240, and 280. Now, f of 0 is 10, so when x equals 0, I'm going to go up to 10. Well, that's 40, so I'm going to put 10 best I can, about right there. Okay, and now when I go to x equals 1, well, my base or my common ratio is 3, so I just multiply the 10 by 3 to get up to 30. About right there. And now when x equals 2, I'm going to take that 30 and multiply it by 3 to get up here to 90. And then when x equals 4, I'm going to multiply that 90 by 3. 90 times 3 is going to go all the way up to 270. Now, I need to know, is this continuous or discrete? Y equals something in terms of x is implied we're continuous. So I need to draw a smooth curve that goes through the scatter plot. And it's going to go forever in both directions. So that's going to look like that. Very cool. And now this leads to my favorite domain. The domain is x is in. And now look, I'm going forever to the left. And I know I'm going up, but I'm also working forever to the right. So I'm going to use parentheses and interval notation. And the reason is because to the left, I'm approaching negative infinity, and I can never reach negative infinity. And to the right, I'm going towards infinity, and I can never reach infinity. So there's the domain, all real numbers right there. You could put a double bar R right there and mean the same thing. Now, let's go to our recursive formula. F of 0 equals 10 again, so we better rescale the y-axis. I'm going to scale it the same way. And then f of 0 equals 10, again, right here. And then we're going to multiply every output by 3. So 10 times 3, 30. Times 3, 90. Times 3, 270. Now, this is a recursive formula, so this is implied discrete. So there's going to be no smooth curve through those points right there. So that's my graph right there. And x is in, and when I'm discrete, all I have to do is write down the set of x values, or every x value of every point in that graph. So I'm going to go set notation, x is in the set, and my first x value is 0, and then x equals 1, x equals 2, x equals 3, and if I had room, this would go on and on forever, so dot, dot, dot. Okay, knowing a number of different forms for writing and graphing equations is like having a mathematical toolbox. You can select the tool you need for the job, or in this case, the form of the equation that makes the job easier. Any master builder will tell you that the more tools you have, the better. In this task, we'll work with our mathematical tools to be sure that we know how to use them all efficiently. As you model the situations in the following problems, think about the important information in the problem and the conclusions that can be drawn from it. Is the function linear or exponential? Does the problem give you the slope, a point, a ratio, a y-intercept? Is the function discrete or continuous? This information helps you to identify the best tools and get to work. I hope you can't hear my dogs in the background. Somebody just rang my doorbell, so it's going to get a little crazy around here. Now, I want to highlight a couple things here. Linear. Most important that you need the two forms of a linear equation. So, if I have a slope and a y-intercept, my equation is y equals m, the slope, times x plus b, the y-intercept. Now, if I have a slope and a point, my equation becomes y equals m. And by the way, this is the way we wrote this when we were first learning this in this curriculum, but now they're changing the notation of the a and the b. All right, and you can continue to use an a and a b, but they want you to start using subscript. So we're going to go with our slope m times the quantity x minus the x coordinate of the point we know, and we call that x sub 1, plus the y coordinate of the point we know, and we call that y sub 1. That's the same thing as a and b here. All right. Now, if I'm exponential, I have y equals ab to the x power, y equals ab to the x power. All right. And now we're also going to write this in a different form just in case we don't know our y-intercept. So here, both of these are going to be in form so we can use any point on the curve. All right. And our a, again, that is the first output, or could be the output of the point we know, and we call that y sub 1. All right. And then our base is still our base. And then, like up here, this is actually x minus 0. Here, I'm going to write this as x minus x sub 1. And in this form, I can use any point on my curve and do the exponential function from there. Very cool. Okay, let's start applying our tools and see how well we can use all of our fancy tools of algebra here. So, number 1, in his job selling vacuums, Joe makes $500 each month plus $20 for each vacuum he sells. Okay, that's pretty important information, so I'm going to highlight that. Write the equation that describes Joe's monthly income I as a function of the n, the number of vacuums sold. And I'm going to start down here because this sets me up for success. All right, and I'm going to begin right here. The function is linear or exponential, or neither. Okay, well, let's see. The pattern of change. We're adding 20 for every vacuum sold. Okay, that's a common difference. That means we're linear. Okay, now let's think about this situation. Is this continuous or discrete? So is the amount of money that Joe is making, is that changing continuously? Or is it discrete? Is it gaining based upon every vacuum that Joe sells? I would call that discrete because he might make $500, he might make $520, $540, and so on, but nothing in between those values. This is discrete. All right, so name the form of the equation you wrote and why you chose to use that form. Well, if I'm discrete, I'm going to do a recursive formula with a common difference. So a recursive function with a, and I'm adding 20 for every vacuum sold, common difference of 20. So let's do a recursive formula. And let's go ahead and use the variables they would like us to use. Write the equation that describes Joe's monthly income I as a function of the n, the number of vacuums sold. So in a recursive formula, I have to start with my initial condition in function notation. So that's going to be I of, and if Joe sells 0 vacuums, he's only going to make that $500. And then the recursion equation right here, I of n equals I of n minus 1. And what's the pattern of change? Well, for every vacuum sold, he gets plus $20 more. Put a plus 20 right there. And there's our model. I of 0 equals 500, and I of n equals I of n minus 1 plus 20. Number 2, write the equation of the line with a slope of -1 through the point -2, 5. All right, well, line, I know I'm linear, and this line is going through a point, and I have a slope, so that would be continuous. All right, so name the form of the equation you wrote and why you chose to use that form. Well, I have a point and I have a slope, so I'm going to use what? Point slope form of a line. Point slope. And now let's go ahead and write our general equation for point slope to help memorize it. So that is going to be y equals m, my slope, times the quantity x minus x sub 1, the x coordinate of the point I know, plus y sub 1, the y coordinate of the point I know. And that is y equals, well, they told me the slope is -1, so I could put a -1 out front. I'm just going to put a negative. You could put -1 if you want. It means the same thing though. And then x minus the x coordinate. Well, the x coordinate of the point I know is -2. So if I go minus a -2, that becomes a +2. And then plus the y coordinate, +5. And there's our equation in point slope right there. Y equals negative the quantity x plus 2 plus 5. Okay, number 3. Write the equation of the geometric sequence with a constant ratio of 5 and a first term of -3. Now, I know you guys could write that sequence right now, but they want the equation. All right? And the sequence would be geometric, so doesn't that mean my function would be exponential? And since we're talking just about a sequence of numbers, we're just talking about outputs. And there's nothing in between those outputs, so it's discrete. That means we're going to do another recursive formula here. So this is a recursive function with a, and I have what? I have a constant ratio of 5. A constant ratio. All right, so let's get started with our recursive function. My initial term, f of blank equals blank. Well, the first term of -3. So that means not f of 0, but f of 1 is -3. All right, there's my initial condition. And now my recursion equation, f of x equals f of x minus 1. And what's my pattern of change? Well, I have a constant ratio of 5. That means I'm multiplying by 5. Beautiful. Number 4, write the equation of the function graph below. Oh, this is good. Well, look at the graph. That's a straight line, so it's linear. And it's a solid line, so it's continuous. All right, and then name the form of the equation you wrote and why you chose to use that form. Well, let's see. Do I see a y-intercept? Yes, I do, right there, -3. And now let's find another point on the line and see if we can determine our slope. This looks like a real clean point right there. And so now I'm going to draw a slope triangle. And to get from this point to my y-intercept, I'm rising how far? 1, 2, 3. And then I'm running how far? 1, 2, 3, 4. So it looks like I have a slope of 3/4. So if I have a y-intercept and a slope, I'm going to use slope-intercept. And that in general form is y equals mx plus b. And in this problem, that would be y equals, and we said the slope, we're rising 3 and we're running 4. That's the slope of 3/4. X plus my y-intercept, and my y-intercept is -3, so plus -3 or just -3. Beautiful. It's great to have all these tools. Okay, number 4, the population of the resort town of Java Hot Springs in 2003 was estimated to be 35,000 people with an annual rate of increase of about 2.4%. So let's think about that. We began with 35,000 people and the population is increasing by 1% every year. Well, that means that my pattern of change, we're going to be multiplying by a common ratio. So this is going to be exponential, okay? And then the function, is this going to be continuous or discrete? Now, think about this. Usually when we're multiplying by a common ratio, we get a continuous function. But think about this. Our outputs will be number of people. So this is actually going to be discrete. All right. But with that, I don't know that I would model this with a recursive function because we're talking about adding all these people. So I think it would be best, even though this one is discrete, I'm going to use y in terms of x. And then I'm thinking to myself, in 2003, the population was 35,000. So we would probably call 2003 year 0 and simply use y equals a times b to the x power. Beautiful. Now let's put this together. So y equals, and remember a, that's how many people we're starting with, 35,000 people. And then my b is my common ratio. Now, the population is increasing by 2.4%. So I'm going to start my common ratio with 1 to represent the number of people the year before, all right? But then I've got to add a decimal to that 1 to represent that 2.4% increase. So 2.4%, I could think of, drop the percent. Let's move the decimal place. 1, 2. So I see a 0.0. Let's do that again. Yeah, 1, 2, 0.024. So my common ratio is actually going to be 1.024. And that is 100% of last year's population plus 24% more with that 0.024 right there. Beautiful. There it is. Okay. Number 5. Jessica's science fair project involved growing some seeds to see what fertilizer made the seeds grow fastest. One idea she had was to use an energy drink to fertilize the plant. Well, I don't know about that, Jessica. She thought that if they make people perky, they might have the same effect on plants. Okay, this is the data that shows the growth of the seed each week of the project. Well, man, looks like the height is increasing. All right, so hey, it's working. And now I look at this data to determine what's my pattern of change. Look at the height, 1.7, 2.9, 4.1, 5.3, 6.5. Isn't there a common difference of what would that be? 1.2 every time. 1.7 plus 1.2 is 2.9. Plus 1.2 is 4.1, and so on. So that means if the pattern of change is a common difference, we're adding 1.2, we're linear. And now, is this plant going to grow discretely or continuously? Well, this is like flowing water. The plant is growing continuously, so we want a continuous function right here. All right, so we need a linear function. And then we think, do we have a y-intercept? Well, my first input is 1, so I don't have a y-intercept. So I'm going to use point slope. And I can use any point I want. I'd probably use this first point right there. So I'm going to use y equals m times the quantity x minus x sub 1 plus y sub 1. All right. Let's see. What's m? Well, m slope is the same thing as a common difference in a sequence, and my common difference here we said was 1.2, so the slope is 1.2. And then let's use this first point right here. My first x is a 1, so see that x sub 1 right there? That's a 1. And my first y is 1.7, so you see that plus y sub 1? It's just going to be plus 1.7. And there's my model right there. This is awesome. Okay, we're going to close this activity with my favorite part. We're going to graph functions. All right, they have given us a model, and let's use their model to produce a graph. So an equation gives us information that we can use to graph the function. Pick out the important information given in each of the following equations and use the information to graph the function. So what do you know from the equation that helps you to graph the function? Well, I hope you guys see y equals mx plus b. This is slope-intercept, and our b is -5. That's our y-intercept. So let's start with the y-intercept. -1, -2, -3, -4, -5. And then our m is 1/2. That's our slope. So we're going to rise 1 and we're going to run 2. So from the y-intercept, I'm going to go up 1 and I'm going to go over 2. And now, is this continuous or discrete? Well, this is an equation, y in terms of x, so that's implied that it would be continuous. So let's just break out our rulers and draw a solid line through those 2 points. And there's the graph. Number 7. Okay, now this is exponential. It is y equals ab to the x. And I go just to the x because I have 2 to the n power. They're using n's, we're using x's. Okay, that's fine. Now, notice there's no parenthesis around the 2 and no number in front of it. Well, that means that this a is nothing but a 1. 1 times 2 to the n. So my y-intercept is going to be 1. So let's put a point right there. Now, my base is what I'm multiplying my output by every time. That's the common ratio of the sequence. So I'm going to take this 1 and I'm going to multiply it by 2. 1 times 2 is 2, so if I go 1 over, I go to 2. Now let's multiply that by 2. 2 times 2 is 4. Let's multiply that by 2. 2 times 4 is 8. Now, continuous or discrete? Well, y equals something in terms of n or in terms of x. So I need a smooth, continuous curve through these points. And there we have it right there. There's my graph of that exponential function. Beautiful. Number 8. What do you know? Well, that's point slope. All right. And I see a point right now because x sub 1 is going to be -6. Let's start this like this. Y equals m times the quantity x minus x sub 1 plus y sub 1. So minus x sub 1, or the opposite of x sub 1, would be 6. So that means the x coordinate of my point is -6. -1, -2, -3, -4, -5, -6, plus 8. Let's go up 1, 2, 3, 4, 5, 6, 7, 8. I think that's my 8 right there. So I have a point right there. There we go. And again, know your x sub 1 and your y sub 1. X sub 1 is always the opposite of this number, and y sub 1 is always this number. So -6, 8. There's the point. -6, 8 right there. And now my m is -2. So that means I have a slope of -2. So that simply means I'm going to drop 2 and run 1. Put another point right there. And this is y in terms of x. So that's implied continuous. So just draw a solid line through those 2 points. And there's our graph for number 8. Number 9. Okay, that's a recursive formula. So this is going to be discrete. And my initial point is f of 1 equals -5, so when x is 1, y is -5. So let's go 1 and then go down to -5. -1, -2, -3, -4, -5. There it is. Now, what's my pattern of change? Well, f of n is the previous term plus 1. So I'm going to take the previous output, -5, and add 1. -4. -3, -2, -1, 0, 1, 2, 3, 4, 5. I think I'm out of room, so I think I'll stop right there. Now, that's a recursive formula, so this function is discrete. There's nothing in between those outputs. So the graph is done right there. Wow, this is fun. Oh man, so that is it. I hope you guys enjoyed this lesson, And have a great day. Now get your ready, set, go done, and let's do it really carefully. Thank you.